Now let's learn what do we mean by data analysis cycle in big data. For that we will learn data analysis process, ecosystem for data science and big data analysis. Where is the wisdom we have lost in knowledge? Where is the knowledge we have lost in information? Said by Eliot. How do we obtain insight from the data? The goal of big data analysis is to use data to get insight and understanding. But how do we obtain insights from the data? If we try to understand this world, data, information, knowledge, wisdom, we call this data, information, knowledge, wisdom pyramid. Data is the collection of measurement and abstraction taken from the real world. What is information is the data that we have been pre-processed and structured so that it is meaningful to humans. Knowledge is the information that has been interpreted and understood by humans so that we can be acted on. Wisdom is acting on knowledge in an appropriate way. If we go back to pyramid world, in this world we have data, we have information, we have knowledge, and we have wisdom. What is data? Is a collection of measurement. What is information? Is pre-processed and structured, so it is meaningful to human. Knowledge is the information that has been interpreted to humans. Wisdom is acting on knowledge. Now, what do we mean by activities in data science process? So, this is the pyramid which we just discussed: world, data, information, knowledge, wisdom. Now, in data science, the world is data source. Data is data aggregation, pre-processing and warehousing. Information is data exploration, which is visualization. Knowledge is machine learning. And wisdom is decision making. So data sources to data aggregation, to data exploration, machine learning, to decision making. Now let's turn this into an example. When we do purchases, that is data sourcing. The transaction data is data aggregation. Summaries, profit, commonly bought stuff, that's data exploration. What items are bought together, that's machine learning. Shopping recommendation, that's decision making. Now, what is cross-industry standard process for data mining? It's a leading software methodology for the world big data analysis process. It is an independent of the software vendors or data analysis technique used. We call this CRISP, Cross-Industry Standard Processing for Data Mining. So if we take this example, evaluation is going to business understanding. Business understanding is going to data understanding, which is also going back to business understanding, but also going to data preparation, which is going to data modeling, going back to evaluation. In the center, we have the data. And this all leads to development or deployment. Now, if we try to understand this diagram, we call this CRISP DM model. Business understanding, which is this: defining the goal of data analysis project, understanding the business needs. Data understanding, which is this: is the data available suitable for the goals defined? Data preparation, preparing the data set for the use in data analysis, merging data sources, structuring, ensuring data quality. Modeling, which is this: extraction of useful pattern from data and creating models to encode these patterns. Evaluation, assessing the model based on understood business need. Deployment, deploying the business model in the environment. Now let's try to understand this by data architecture. So we have applications, we have data storage, and we have data sources. So we just discussed in our previous diagram data sources, which is like a world, or purchases as an example. And then we have data storage, where it's getting storage, and the applications. Within data storage, we have data analysis as well. Traditional sources like application databases, big data sources, social logs or sensors. This goes to RDBMS, Relationship Databases Management System, NoSQL Warehouse. Hadoop, which we will discuss further in this video. This goes to business analytics, customer application, backend process, packaged applications. All these applications are part of big data architecture. Now let's learn multi-layered big data analysis application. So we have these data sources, which goes to data storage layer, RDBMS, NoSQL databases, all the databases. MapReduce, Spark, Storm, Flink, Spark, ML, LLB, TensorFlow, PyTorch, end user application. Same time, we have data storage layer, generic processing layer, machine learning layer, goes to end user application.